Friends, have a greetings of the day. This is Professor Dr. G.S. Wajire from Department of Electronics, Sri Shivaji College, Akola. Today's topic of lecture is effect of negative feedback on gain and noise. Friends, already we have discussed various advantages of negative feedback. Today, we will discuss in details about the stability of gain with negative feedback. In other words, we can see we will discuss about the effect of negative feedback on stability of gain. As you know, the gain of an amplifier may change due to many reasons like change in power supply, ambient temperature, load resistance, aging effect of component, and so on. But the ability of any amplifier should be in such a way that it should oppose the change in gain due to any reasons. Here, it is expected that any kind of amplifier should oppose the change in its gain due to any of above reasons. The gain of an amplifier with negative feedback is given as AVF equals to AV upon 1 plus AV into beta. Already we have derived this equation 1 in previous lecture. Now we have to differentiate this equation. Here we have to use the formula of derivative of U upon V. Here U means AV and V it means 1 plus AV into beta. Now taking derivative of both sides of this equation 1, we get on left side we get derivative of AVF equals to derivative of second side, of course by using this formula, and we get here 1 plus AV into beta into derivative of AV minus AV into derivative of 1 plus AV into beta upon 1 plus AV into beta whole square. Now by splitting these terms, we get the equation like this: derivative of AV plus beta into AV into derivative of AV minus beta into AV into derivative of AV upon 1 plus AV into beta whole square. In this equation, see the second term, beta into AV into derivative of AV minus beta into AV into derivative of AV. Here this first term is positive and second term is negative. So both terms get cancelled. And the final equation that remains on left side, derivative of AVF equals to, on right side we get derivative of AV upon 1 plus AV into beta whole square. Let us take this as equation 2. Now in this equation, the term derivative of AVF is nothing but the change in gain with negative feedback, and that second term derivative of AV is nothing but the change in gain without feedback. For your kind reference, we have taken the same equation in this equation as the term 1 plus AV into beta whole square is always greater than 1. So from this condition, it is clear that derivative of AVF is always less than derivative of AV. Let's take this equation 3. And from this equation 3, it is also clear that the change in gain with negative feedback is less than the change in gain without feedback. Hence, it is very clear, it is very explicit that the gain is more stable with negative feedback than the gain without feedback. And ultimately here we have to conclude that the negative feedback keeps the gain more constant, more stable than without feedback. Come to next topic. It is effect of noise and distortion with negative feedback. Or in other words, we can say effect of negative feedback on noise and distortions. As you know, the amplifier just increases the strength of its input signal, whether it contains information or some noise along with the information. This noise or distortion may be introduced in the amplifiers because of their strong tendency or due to sudden temperature changes or stray electric and magnetic field and so on. In general, the performance of any amplifier mainly depends on its noise. Actually, the noise is an unwanted and undesired signal that creates the disturbances to the desired signal contents in the system. However, it is unwanted and has to be removed. For proper understanding of the term, let's consider capital D as a distortion without feedback and DF as distortion with negative feedback. Then the equation for such distortions is written as DF equals to D upon 1 plus AV into beta. Let's take this as equation 1. Now, as in last case, in this equation also, the term 1 plus AV into beta is always greater than 1. So, from this condition, it is clear that DF is always less than D. Here, DF is distortion with negative feedback and D is distortion without feedback. We are taking this equation 2. And again, from this equation 2, it is clear that the distortion and noise level with negative feedback is less than that of without feedback. So again, here we can conclude this topic as the negative feedback reduces the noise and distortion levels. This characteristics of negative feedback is advantageous in case of amplifiers, which reduces the noise and distortion level. And in the same way, in case of stability and gain, we can say that the negative feedback increases the stability of gain. So again, this is advantageous feature of negative feedback, that it keeps the gain stable or constant. So friends, let's stop here. Thank you very much.